Hello, everyone. I'm Jacob. Today I'm going to talk a little bit about what's next for Solidity and a little bit about Argo, which is the collective building Solidity and a bunch of other tools. Perfect. Okay, so I wrote my first smart contract in 2015, which has been a while. And back then there was absolutely no tooling or anything to help you out. So it was pretty raw. This is the snippet from my bachelor thesis about Ethereum, and yeah, some of it looks pretty similar, but also a lot has changed. Um, and yeah, after that, I did a bunch of stuff, and I'm now doing deferral for the Solidity language. Okay, so where are we currently with the language in 2026? And a little bit about the pain points that people are still facing with Solidity. So Solidity has been in production for 11 years. Um, and the latest release we have is 0835 from April, which introduced a couple of interesting things. One of them being an experimental flag that now has an SSA CFG pipeline, which my colleague Moritz will speak much more about right after my talk. It's maintained by the Argot collective, which is a spin-out of the Ethereum Foundation. We've been independent since 2025, so about a year. And yeah, I'm also going to talk a little bit about what that means and what Argo is. But first off, we also fairly recently had our developer survey, and the biggest pain point people keep on facing is the stack too deep error. I'm not going to go too much into what it is. I'm sure Moritz will explain that further. But basically, people have been running into this for years and years, and the more experience the developers have, it seems they run into it more and more frequently, which makes sense. But we are fixing this. And yeah, as I said, we will talk in depth in the talk after this one about how we are doing that and what else we are improving with the SSA CFG. So yeah, don't run away after my talk. Please stick around. And yeah, the other thing is that, as I said, we've been building Solidity for 11 years, which has its pros and cons. But there's been a lot of patching in the code base. It started out as one thing and might not have been designed, or no one really knew where smart contracts would be going. And there's also been a bunch of research and improvements happening in the general programming language landscape. So we are also working on, let's call it a re-implementation of Solidity that kind of take some of the things we've learned over the years and try to make a language that is up to date with the current programming languages landscape. So we're doing core Solidity, which is kind of a redesigned language and type system, but uses the same backend. So everything like the pipeline kind of we will be able to reuse. So all the work that we put into the compiler at the backend over the years will still be relevant, and all the work we're putting into SSA CFG will be reused. And here, yeah, so now I'll show a little bit about what the language looks like, or what you can do. I don't know if it's too small for the people in the back. I hope you can read it. Here's an example of kind of like a payment handler that on the left side you have the example in Classic where you have a struct, and basically this struct, there's not really anything keeping you from creating invalid payment types. And the only way you can kind of shield against it is by the like if statements or requires that we do on the left side, whereas on the right side we have pattern matching and abstract data types, which allow us to define exactly what a type of payment, or what a payment type looks like, and this way we can ensure that we only allow for the given payment types. And in the same way, if we decide to include a new payment type like ERC 1155, nothing would really help us on the left side in Classic to ensure that we cover all cases, whereas on the right side in Core, the compiler would tell us whenever we are missing a case, or we don't handle it correctly, which is a very nice feature of a language, and probably a lot of you are used to something like this from some of the languages you use nowadays. So one thing that I think is like quite interesting that I've read about recently is that in aviation, you go to great length to make it as difficult for pilots to make mistakes, because pilots and humans will always make mistakes, but it's kind of our job to make it as difficult as possible to make these mistakes. So I think designing a programming language with this in mind makes a lot of sense, especially when it's a programming language that holds billions of dollars, hopefully trillions at some point in the future. But yeah, you definitely want to make it as difficult for the people writing smart contracts to make mistakes. And here, yeah, there's a nice error message example from what it probably will look like. And this basically also, like, if you have this pattern match I showed before, you'll have something that it like basically compiles to what a careful developer could also write in a Joule switch statement, and it comes at no extra runtime cost. So basically, it compiles down to this Joule switch, which is just yeah. So just because we have this pattern matching doesn't mean that we have any extra runtime cost. Another thing that a lot of people have been asking about for a very long time in Solidity is a standard library. Currently, stuff like ABI encode and a lot of other language features is built into the compiler, which is written in C++. But now in Core, we are going to have a like very small core language and a standard library, which means that we can implement all these things in the standard library, and we can, let's say, move faster, and we don't have to make a new version of a new release of the compiler just to have new functionality in the language. So I think it's a very healthy split. And a cool example of this is just last week, we had someone implementing memory slices in around 50 lines of code in the standard library in a couple of hours. And he told me after that this took like a month to build into the compiler back in the day. So I think this is a pretty powerful showcase of how having a standard library in a smart contract language can be very useful. And we also have generics in the language, which, again, compared to how, let's say, Forge, as Forge standard library, they have 381 handwritten log functions, whereas in Core Solidity, you can just have one function per arity, which is more elegant, smaller surface for mistakes. So I think these things add up to something that will actually be a very comfortable language to use, that also makes it harder to include or introduce bugs in your code, because a lot of the things will be caught at compile time. Yeah, I will not go too much into detail with like the inner workings. I have a talk on Wednesday at DAppCon you can check out if you want to know more. But since I promised to also talk a little bit about Argo, I'm keeping it very high level here. But the core language sale is basically 8 primitives and 1 type. And one of the things we wanted to do is make sure that the language is small enough that it can be formally verified. And we plan to do that. Yeah, so we do have a couple of external contributors already, which have contributed with some really great things. We have Aksik, who some of you probably know. He's been helping out a little bit lately, and he built the beacon chain deposit contract in Core, and he also built a multisig and provided a lot of very good feedback about the current state of the language, and just in general polished it up a bit. Then last week we had an external contributor also writing a Uniswap v2 pool and providing a bunch of feedback in the forum. So it's really nice to start to see that people are showing some interest and helping out with like whatever they find while they try it out. So I encourage anyone here who'd be interested to also give it a go and open a thread on our forum or come and find me if you have any feedback. You can play around with the language, but please don't use it for production yet. That would be a little bit risky, I think. We also have recently released a blog post about pattern matching and pattern matching in core Solidity, which is quite interesting, I would say. And if you're not too familiar with pattern matching, it's definitely worth a read, especially if you're a Solidity developer. We also recently merged our first version of the module system in core Solidity. And as I mentioned earlier, the 0835 version of Solidity also has a comp time built-in and this experimental SSA-CFG code gen. So it's all starting to come together, and we will have the foundation to be able to really have a language for writing smart contracts that fits the, let's say, state of programming languages in 2026. Sorry? Of classic or core? Sorry? I don't know if there will ever be a version 1. I think the team got into some interesting versioning way back, and now we have like 0835, which is, should probably have called it gotten rid of the 0, right? But that's too late by now. Yeah, and we also working on a playground that people can use to try out the core language. And also, like, it doesn't mean that we're not stopping work on classic, but I think it's just I think it makes sense to talk about core as the version or the language that we should focus on in the future, but we will be maintaining classic, of course. Yeah, but give it a go. Don't expect core Solidity production readiness in 2026. Do we have a time, Martin? Do we have a time? Because how much time? Okay, I'm done. Okay. Yeah, so a little bit about the people and the collective building all these things. So we are Argot, and we spun out of the Ethereum Foundation around a year ago, as I mentioned. We're around 25 people with slightly different backgrounds, but all within the computer science field for sure. Most of the people come from the Ethereum Foundation, were there before we spun out. But there's also been a couple of additional hires, myself included. I'm the latest person to join. And yeah, as I said, independent entity since 2025. But for the last 2 years, Argot has kind of worked also within the EF the first year as an independent thing. And one of our goals is to be a credible, neutral home for Ethereum's core infrastructure that is not like the clients, the consensus and the execution clients, but like more the core tooling for writing smart contracts. A little bit about how we are set up. So we are a not-for-profit and we run flat. There's no management layer. We're consent-based and voting on things that are like bigger decisions. And it means decisions take longer, but from my 4 months here, it feels like we often land on actually the best decisions because we take the time to discuss it and listen to different points of view instead of just one person that feels strongly for something making a decision. And also there's a very high autonomy of the day-to-day work, which I think empowers people to get stuff done and take initiative. It's funded in open. We have 5 years initial runway from the Ethereum Foundation that we're topping up with public grants when we can get it. And we release transparency reports twice per year that you can go and find on our website in case you're interested in knowing how we're running things. Another thing that I have dear to my heart and that I really like that we're doing is we run the whole organization on open source tools where possible, and we self-host as much as possible. And it's a little bit rough around the edges. I'm sure some of you have tried using something like CryptPad or whatever, and it doesn't always go too well, but we still believe that it's important to do it so that we can provide the feedback for these tools and so that they can become better over time. And I often hear people say that we should all use open source, and then when they pull up their slides or whatever, it's a Google Slides, or they run a Discord server for their community or something like that. And I think we should not accept this. We should really try as a kind of as a whole ecosystem to do better and use more open source tools where possible. And we definitely also subscribe to a lot of the values that the EF recently coined crops. We've been doing it like since we started out in Argo, and if we're not the ones doing it, then who are? And lastly, we also do give some grants out ourselves to some of the tools and the open source infrastructure tools that we actually rely on. So recently we gave a grant to a team that is helping build debug, for example. Lastly, I'll just quickly go over the projects that we're working on. We have HEVM, which is a symbolic execution engine for the EVM. For example, the tool Echida is built on top of this. We have Sourcify, which I hope most of you know what it is. It's an open source, decentralized source code verification tool. And I really think this is actually a very cool tool that more people should be using, and a lot of people are. They have 32 million verified contracts across 325 chains. And they are also one of the projects spearheading the open, the clear signing initiative that I believe my colleague Khan will talk more about in about an hour on this stage. So also stick around and check that out. They're really doing cool work. We have Fei, which is a second programming language that we are also building, a statically typed smart contract language, and it has like similar syntax to Rust and immutable by default. Give it check it out. They also recently had a bigger release. Then Debug I mentioned, which is aiming at having a standardized debug format or debug information format for the EVM so that we can have proper debugging, which also hasn't happened in 11 years. Then ACT is a formal specification language for EVM smart contracts. And yeah, as you all know, everyone's talking about formal verification these days, and we've been working on this for quite a while as well. And if you're interested in learning more about this, we have Anya from the team gave a very nice workshop on this from Prague a month ago. So you can find this online and get a good idea of what you can do with this tool. Yeah, so I think I'm almost through. Yeah. Anyway, give it a go. Try it out, especially core Solidity, and let us know what you think. Check out our website, argot.org, if you want to know more about our roadmaps and our future plans. And I think that is it for me. I think we'll skip the questions to see if we can get a little bit back on time, maybe. And then I'll hand it over to my colleague, Moritz. Yeah. And